Problem number 1942. The number of the smallest unoccupied chair. There is a party where n friends numbered from 0 to n-1 are attending. There is an infinite number of chairs in this party that are numbered from 0 to infinity. When a friend arrives at the party, they sit on the unoccupied chair with the smallest number. For example, if chairs 0, 1, and 5 are occupied when a friend comes, they will sit on chair number 2. When a friend leaves the party, their chair becomes unoccupied at the moment they leave. If another friend arrives at that same moment, they can sit in that chair. You are given a 0 index to the integer array times, where time I equals arrival and leaving, indicating the arrival and leaving times of the ith friend respectively, and an integer target friend. All arrival times are distinct. Return the chair number that the friend number target friend will sit on. I think the most tricky part is that when a friend leaves the party, if another friend arrives at the same time, they can sit in that chair even though it is not the smallest chair. If we don't have this, like if every friend comes, they had to sit on the smallest number of chairs, then it's easier. That means we can maintain a heap that is that will be smaller than the current chair, and that means the chair that has been occupied and then unoccupied chairs, it will be stay in the heap, so that every time the friend comes, we can check if the heap is empty or not. If it's empty, then we will give them a new chair. But if it's not empty, then we will have the minimum number of chair to the friend. But that I think we must modify some of the part that when somebody is leaving, and it can assign a chair to the friend that is coming right now. So like example 1, friend 0 is target friend I1. I think arrival and leaving time will be positive integers, and it will be only, the length will be 2. Correct. Target friend will be in the length of n. Like this, friend 2 arrives at time 4 and sits on chair 0. Or is it? Yeah, like if I'll say, let's say if I have another friend, okay, arrived at 3 and yeah, if the one that if somebody okay, I'll say let's have sure, like when it is this condition, or maybe just we can first do a thing without this, like so I will have like an index, I'll say current chair, then and also I think we should sort the time of arriving and I'm thinking like arrive to yeah, like okay, I have a question, like if many people arrive at the same time, who is going, oh, its arrival times are distinct, okay. And then if many people live at the same time, which chair is he gonna to select? Is this still the smallest number? this, and which chair will number 2 friend sit on. Let's first return 0. So sit on 0. Then if the first chair is so I think I want to use a heap to okay, so when a friend comes by, I would if the heap is empty, then I will give it a chair from the current variable. So, and the heap, and it's a main heap. So when friend arrives, if heap is empty, then current plus then return current, and then current should plus 1. Else, if a heap is not empty, then we'll pop the heap, the minimum from the heap, and when the friend leaves, then so I have to know its seat number. If its seat number is let's say seat number is equal to current plus 1, current minus 1, then we can get back current can minus 1, or I think seat number will not be larger than current. Yeah, it's not possible. But yeah, if seat number is smaller than current, minus 1. Then we will have it added to heap. So heap push seed number. Okay. Else, I think else will do nothing, but I don't think it's going to happen. Yeah, and this time complexity will be, but yeah, when a friend arrives, we have to yeah, so the order of friend coming and leaving is important. And its seed is also important. So I think I have to maintain like an array that yeah, like friend 0 has like friend I will have seed number. Yeah, friend I seed number. Okay, so and also it's we need to for loop, or should we use like a dictionary like at each maybe we should have arrive I means the first friend yeah, I'm thinking of how to loop through this array, this times array. I think I have to, yeah, like sort this, but it has more like times I, and it would be friend arriving or leaving. So when I loop through times 0, it's the first. Let's say, okay, arrival will always start at 1. Well, not really, but yeah, the smallest arrival time will be 1. That's maybe has t. So t will be I need, like, for each time I need who has arrived, who has leave, and it's chair, like arrive, leave, who is leaving. Oh, maybe we can do like we should reorg this times matrix and become like so for I in for like times time in times, let's have a t Okay, I'll just first sort the sort the times with arrival time. Sort times key times sort key is I forgot how to. Okay, I think I will have first of all, I'll have friends array that will keep track of the seat number each friend remains. The seat number that each friend seated. Okay, so first of all, we'll have n as the length of times. That means we have n friends. So for the friends array, I'll have say seat, or maybe I'll say seat, and it is let's have n with the number of n, and we will have an arrive time that is, okay, I'll have sit I will be friend I, the I's friend seat number, and arrive will be the maximum between let's say the max maximum time, I say max t, it will be maximum between for A and L in times, so A and L, and arrives will be -1 with the size will be max time plus max time plus 1, and leaving, arrive, leave will be the same, and we will have to now create this array, like for arrive I means at time I, the arrives it is the friend that arrives at time I. Yeah, so we will for loop arrival and leave in times, so and I need I index. Okay, so it would be like enumerate. Let's say no. Let's have range n, and we'll have I. So for yeah, I means the friend's number, so I will have, okay, times I will be A and L, arrive and leave time, and for arrive A we'll have I, and for leave L we'll have I. Okay. This we finished setting now, and so that's implement this stuff when a friend arrives. So we will first we will for loop the for loop I in range and zip arrive and leave. And that's at A and L. If L is larger than negative, then it means somebody is returning back the seed. So let's check. Seed equals I'll say this is friend. So friend. Oh, we haven't created friends. Oh, we have seed. This is friend. And for arrive, this is friend arriving, so I'll say friend A and friend leaving. So if friend A is larger than, if somebody is leaving, then it should return its seed. So if least, okay, so its seed will be friend, will be seed, friend A. Okay, we cannot use, so its seed is this. If set S, if S is equal to, okay, I'll say current is 0 and heap is empty. Okay, so if S is equal to current minus 1, then current will be minus 1. Else if seed number is smaller than current minus 1, then that's push to our heap. So heap with seed number. Okay. If A is larger than 1, and if friend friend leaving, oh, it's leaving. If leaving, we'll first leave, then we'll first deal with leaving and then deal with the arriving. Then if a friend is arriving, if heap is not empty, then we will give it a seed. friends, sit friend of arriving will be heappush with hip. Else, if heap is empty, then we will assign sit friend A. Arriving will be current, and current will plus 1. And since the target, it's asking for target friend, so we should stop when the target friend arrives. So here, if friend A equals target friend, return its seed. Target friend is 2. Okay, maybe let's print. We can print our leave, print our arrive, leave, and seat. Maybe hip and current. Okay, first thing we are at hip is always empty, so for this arriving 0, okay, so this will get 0 and this will get 1. And we did not deal with multiple leaving. Okay, so it's a bit annoying. Yeah, maybe we should do it like for friend in times friend, arrival and leaving. Arrive A, leave. I think we should have like yeah, for leaving it has to be matrix or so. I think I'll have like if leave L equals -1, then we'll have okay, if leave L is already larger than -1, then it means it has already a friend leaving at that time. Then yeah, we should use it as an array. So for this friend, then we should if L will become leave L. Or maybe let's just leave L push friend. And it is like this. Not sure if this works. And if a friend L is not empty, then we should for loop friend L in yeah, the set will be FL if S is yeah, let's see if this works. Oh, append with the append. Oh, then it's correct, but others are wrong. Let's see how it works. Print, arrive, and leave. I'll say none, and L will be I want it to be a default array, like, okay, maybe just Python array is default array. Okay, I think it's not. We'll have none. And okay, if leave L already has an array, then leave L appends friend. Else it would be leave L equals